All right, 11.5, angle relationships in circles. So today we're going to be interested where we have different segments. We have tangents, we have chords, and they're interacting and crossing somehow in the circles. And there's three theorems that we're going to learn to help calculate the angles and help calculate the arcs. So I'm going to kind of jump in and refer back a couple lessons to kind of try to put all this into perspective. But basically, early in the chapter, we learned that when you have a circle and you have a central angle, meaning the vertex, right here, the vertex is a center point. If the vertex was in the center of the circle, whatever the angle was, say that this angle is, maybe 80 degrees, then that meant that the arc measure matched it and was also 80 degrees. So they were just equal. So basically, the central angle equaled the arc measure, and we're talking about the intercepted arc, the arc that angle, they say subtends. I don't really use that lingo too much, but it's the angle that's trapped there with that arc. So we're going to look at three different scenarios, and the key idea, this is the most important thing I can drive home, is the vertex of the angle determines which theorem you're going to use. So notice in the first one, this vertex was at the center of the circle. All right. So when the vertex is at the center of the circle, it's equal to the arc measure. Now we're going to have three different scenarios where, if you notice in this first scenario, the vertex is on the circle. So vertex on the circle. Over here we have a vertex is in the circle. Now, not at the center point, but it's inside somewhere. And then here we have the vertex outside the circle. Those are the only scenarios that can happen. Vertex outside, vertex inside, vertex on, or vertex in the center. All right, so it's kind of a special case of the vertex in. So let's go ahead and let's get into the theorems, and then we'll crank out some numbers here. I'm going to slide down, give myself a little bit more room. So I'm going to just really quickly at the top, I'm going to put in, so this was vertex on, this was vertex in, and this was vertex outside. All right, well, here's the deal. If the vertex is on the circle, okay, then the angle is 1/2 the arc measure. The angle is 1/2 the arc measure. So, and usually I'm going to know one side or the other. I'm either going to be given the angle and I need to find the arc, or I'm going to be given the arc and I need to work backwards and find the angle. But this equals and this 1/2 is always going to be there. So the angle is 1/2 the arc. Well, in this problem, they give me the angle. They say, hey, the angle is 80 degrees. So I know that the arc out here, we're trying to find the measure of this arc. That's where my question mark is. So 80 degrees is 1/2 the measure of arc RP. Okay. Now, if you want to, if it makes you feel better, just call that X. And you could also just write this, the angle is 1/2 of X, if you'd rather solve it that way. Either way, it doesn't matter to me. But I'm basically going to double. I'm going to multiply both sides by 2. And I find out that my angle is 160 degrees. So this arc, not the angle, the arc measure is 160 degrees. So going back up here to the top, the arc measure is 160. So the measure of arc RP is 160 degrees. So the angle is 1/2 the arc. You also could say that, 2 times the angle equals the arc. That would be saying the same thing. But the angle is 1/2 the arc. All right, let's go over here and let's take a look at the in scenario. So when the angle's inside, all right, when the angle's inside, I'll do this in red, the angle is 1/2 the sum of the arcs. All right? The angle is 1/2 the sum of the arcs. So we're trying to figure out what this inside angle is. And let's call this inside angle x. So I'm trying to figure out what x is. And remember, since these are vertical angles, they're both the same. They're both x. But I'm trying to figure out what that angle is. So angle x is 1/2 the sum, 1/2 the sum of the two arcs. And the two arcs are 37 degrees and 65 degrees. So what would that inside angle be? Well, I'm going to go ahead and I'm going to work this out. 1/2, and I'm going to do order of operations and add up my parentheses first. That is 102. And so 1/2 of 102, x is going to be 51 degrees. So this little angle right inside here is going to be 51 degrees. Now another way to word this is, because really when you add two numbers and you divide it by 2 or you take a half, you're really finding the average. So another way to think of this one is the angle is the average of the two arcs. If that kind of helps you, then think of it that way. So when you're inside, the angle is half the sum of the two arcs. And now finally the last scenario. The last scenario, I'll do this one in purple. The last scenario is our vertex is outside, so we're trying to find x. So on this one, the theorem is the angle is 1/2 the difference of the two arcs. So the angle is 1/2 the difference. So the angle is 1/2 the difference of the two arcs. And the two arcs, and I always want to do big, the big one, take away the little one. So 200 minus 74 degrees. So x is 1/2. 200 take away 74, that is $1.26, I believe. And half of 126 would be 63. So the answer to the question is that's 63 degrees. So 3 scenarios if you can remember them. Okay. Number 1, if the angle is on the circle, it's equal to half of the arc that it intercepts. Okay. Number 2, if the vertex is inside the circle, the angle is half the sum. And then number 3, if you're outside the circle, the angle is 1/2 the difference. So I don't know if there's some little mnemonic device or how you can memorize that, but maybe we'll develop something here over the next couple of days, some little jingle or some way to kind of keep all that straight. Some people like to just kind of make a little chart. So let me kind of scroll down and see, so maybe, I don't know if this will help you or not, but you could kind of just do like this. If you're on, if you're in, if you're out, here you have 1/2, so the angle is half the arc. If you're inside, the angle is 1/2 the sum of the arcs. And if you're outside, the angle is 1/2 the difference of the arcs. So I don't know if this might be a way, like if I was limited to a little note card or something like that, I might have that on my sheet to kind of cliff note the 3 theorems up above. And sometimes some math classes you're limited as to the amount of notes you can use, so that might be a strategy you could kind of use to help you out. All right, let's do some examples. We need to find the measure of angle STU. So angle S to T to U. So we're trying to find this angle right here. We'll call it X. So I'm trying to figure out how many degrees that is. Well, the very first thing you need to do, number 1, is where's the vertex? That's the big question you always have to ask yourself first and foremost. Where is the vertex? So for this one, the vertex is right there on the circle. So I'm on the circle. So I know that should be half the arc. So I need to do 1/2 of 166 degrees, which would be 83 degrees. So there's the first one. Number 2, find the measure. So I'm going to get rid of this here. Find the measure of minor arc SR. So go S to R the shortest way possible. All right. Well, I got to kind of look and see, well, what angle? Because now on this one, I know the angle. I know the angle, but I got to say, what angle created that arc? Well, the angle that created that arc is right here. There's the angle. So if we know that the angle is half the arc, okay, because our vertex was on, this one was on. So let's plug in what we know. Well, this time we actually know the angle, but we don't know the arc. So we'll call the arc X. That's what we'll call this arc measure over here. So really I'm going to double it. Okay, if the angle is half the arc must be double the angle. Using algebra, I would times both sides by 2 here, and I would find out that it's 142 degrees. So the arc is double the angle, or the angle is half the arc, however you want to think about it, but that's the relationship there. Could we find the measure of angle RST? So using some facts that we have already, let's kind of write down what we have. So we knew that this piece over here is 142. We know that the other side is 166. So I think we have the 142. We have the 166. And we should be able to now find this piece right here. So let's see how we do this. We're going to add up what we have. 142 and 166. 8. That's 0. So we're at 308. So when I subtract that from 360, I end up with 52 degrees. So the arc is 52. And what's the question? We wanted to find the angle RST. Well, RST is this angle right here. So since our vertex is on, and let's just call this X, our angle is 1/2 the arc. So X is 26 degrees. So that was the measure of angle RST. All right, so that whole first example, everything in this one for this example, the vertex was on. So we're using just half the arc. So I imagine these examples on the back, they're going to be in different places. So let's peek at number 2. Number 2, first thing I look at is find the vertex. The vertex is in the circle. So I know that the angle is half the sum. Okay, angle is half the sum of the two arcs. So let's crank out and see what we got. So we're trying to find the measure of angle ABD. Let's just call it X. So the angle is 1/2 the sum, and then my two arcs are right out here, 37 and 65. So that would be 1/2 of 102. So X is 51 degrees, which was the measure of angle ABD. I just thought it'd be easier to call it X. When you're solving it, I think it's easier to just use X than use all those symbols and letters. But that's just me. You can do it however you want. All right, number 3, where's the vertex? The vertex of the angle is on the outside. So this one is where the angle is half the difference, half the subtraction of the two arcs. So the angle is half of the subtraction of the two arcs. Now, some people are like, hey, couldn't you distribute? Well, yeah, you could, but it's going to be more work. I think it's easier to just do what's inside the parentheses first and then go ahead and times by 1/2. So this comes out to be 76. Half of 76, I believe, is 38. So x is 38 degrees, or otherwise known as, oh, I guess this one was just x. We didn't have to use any other letters. I guess I could have said QPS or RPS or something like that. All right, moving right along. We've almost got this set of notes licked. Little bit different scenario here. So again, first thing is, where's the vertex? It's outside. So the angle is half the difference. This time I don't know the two arcs, but I do know the angle. So the angle is 25 degrees. The big arc, which comes first, that way I'll get a positive number when I subtract. The big arc is 83, and the little arc is x. So now this one's going to require a little bit of work. And basically you have two scenarios right now. Okay, I'm just going to kind of write them over here to the side. Scenario number one is you could distribute the 1/2. Okay. Now, I don't like that because then I got to do half of 83, then I got to have half an x, and I got to deal with that. I think it would be easier, okay, this would be my method, is I'm going to multiply both sides by 2, by the reciprocal. And it makes things really nice, so I'll show you what I'm going to do. I'm going to multiply this side by 2. Actually, it might look a little bit better if I do it in the beginning. I'm going to multiply this side by 2, and I'm going to multiply this side by 2. So basically I have 50 degrees equals 2 times 1/2 just become 1, and it kind of just goes away. I made that 1/2 go away by multiplying it by 2. And now since there's nothing outside the parentheses, I can pretty much just drop them because there was just a 1 outside there, and a 1 doesn't do anything. And now I got to be careful. I'm going to subtract, you might be able to do this in your head. 83 take away what gives you 50, and you might just be able to get the answer by doing that in your head. Or, the mathematical way would be to subtract 83 from both sides. You'll get negative 33 equals negative x, and then you can either divide by -1 or times by -1, and you'll get to this answer. But it probably would have been easier to do it in your head. All right, so let's come over. Number 5 is looking a little bit crazy. There's a lot going on. Ultimate goal, find the measure of arc LP. So my ultimate goal, when it's all said and done, is find out how big that arc is. Well, what would be really nice is if I knew this angle right here. I have the 80, and I would have this arc, or not have this arc, but I would have the angle, and I would have 2 out of the 3 pieces, and I could solve it. But I don't think that's gonna quite be enough for me. So this one's gonna require some extra stuff. We're gonna have to find some other things along the way. And sometimes you may find that you do the problem and you do some extra things that really weren't necessary, but hey, I don't think that hurts. Well, let me look at the clue. I had a couple things. I had 26 degrees was angle Q. So the 26 is actually this angle back here. So I'm going to kind of get rid of that. 26 degrees is over there. So I think, looking at the numbers I think I have an angle, and I think I have an arc of 80. And then the other arc that goes with that 26 is this little PR. All right, so let's call this X. I want to find that out because they're telling me that the distance from L all the way to R, they're telling me that this whole arc here all the way is 100. So if I could find X, I think what I could do is LP is just going to be 100 degrees minus X, or minus arc PR, I guess I could say. So I'm going to try to find PR. So let's do this. So look at your vertex. Your vertex is outside. So if you're outside, the angle is 1/2 the difference. I know the angle, it's 26 degrees. I know the big arc is 80. And what I don't know is the little arc, which we're calling x. Now remember, it's really arc PR, but I've kind of renamed it as x. I've identified x as the letter for it. So I'm going to do this the same way I did the last one. I'm going to multiply both sides by 2. So this step is going to be multiplied by 2, and I'll get 52 is 80 take away x. And I'm going to do this one in my head. You know, if I do 80 take away 52, x is going to end up being 28. So I really still haven't solved the problem, but now that I know that x is 28 degrees, the measure of PR, now I can do 100 minus 28 degrees, and that should tell me what LP is. LP is 72 degrees. So that problem was a little more involved, and some of them are going to be like that. You may have to do a little bit of work. You know, there's other ways to do this problem too. I mean, I honestly could keep on going, and I could have did some things like, if since LR was 100, I could have worked backwards from LR, and I could have got this angle because it's half the arc, and I knew it was 50. You know, so now I have a triangle here. I have 50, I have 26, that's 76. If you subtract it from 180, that would be 104. So I could have got this angle as 104. And then I could play the linear pair game, and this angle is 76. And, you know, I could have used that. I could have said the angle is the half the sum of the two arcs. So a whole bunch of things I could have did there. So I don't want to pigeonhole you into solving problems a certain way. You can be flexible and use other methods. Whatever it takes to get there. All right, that'll wrap up our 11.5 notes. See ya.